the database itself,
Mhm.
and we can able to pull the data from there to the front end or whatever. But so I think we are going to do that, but I'm just wondering. So if you want to do any sorting on the front end, that will be done in the front end or in the database itself.
That's a great question. It all depends on the data. Sometimes you'll do it on the front end, sometimes you'll do it in the back end. In terms of it's really application specific. Normally, you say, well, you want to push as much of the sorting to the back end, right? Because the back end knows the most about the data.
Okay.
And the thing is, if you get any sizable chunks of data, when I say sizable, we're talking pretty small, thousand, let's say 1,000 data points or something. That takes some time to transfer between the back end and the front end. And so typically what you'll find is that most of the sorting is done on the back end. And you use query parameters, which we haven't really talked about quite yet, but it's part of that URL. Or you can use, payload body stuff or any of those types of things in order to say, hey, here's my cursor, meaning where you are in the total data. And then you can put in the headers, the HTTP headers, like the total count. Or actually structure your JSON response body with like a pagination, what we'll call pagination object. And that pagination object will contain a number of different things about it, like where you are, what the total number, what the next record is after how many you requested, all those different things. So you can, as a front end, kind of manage your own paging, what we call paging, right? Because I mean, it makes sense, the word paging, right? You're just paging through
Yes.
data. It's
Yeah.
all that, right? And so typically we'll push that to the back end, but sometimes if we get lazy or it's like, look, I mean, it's okay if the client has to wait a little bit of extra time because we're front loading the cache or whatever in the front end. Sometimes, you'll take that 5 seconds or whatever to load all the data, then the front end can sort it. So it really depends on how much data you're talking about and what kind of sorting. If really all your sorting is sorting in ascending or descending order, you can probably do it on the front end because and just request certain amounts, right, of data because you always kind of guaranteed that you're going to be within some sort of sort. But if you're trying to sort things like, especially like complex sorts, like allowing the front end to sort by multiple columns of data, right, or multiple fields in your JSON, in alphabetical order or based on a kind of keyword, but based on keyword or something. Yeah, you kind of got to do that in the back end because there's no way to load everything front end and then search it all, right? That's just not reasonable performance wise. So it's kind of split. Most of the time, you'll see some of the most of it done in the back end. One of the more complex things we do as architects, front end, back end architects, particularly from a front end perspective, is paging. Actually, it's a very frustrating thing that has a lot of implications on how you design your APIs, how you design your data, and everything. And it's actually one of the weaknesses I think of GraphQL. If A lot of people say it's a strength of GraphQL. I talked about different API strategies and that query language that Facebook did GraphQL. A lot of people will say that that's one of the strengths of GraphQL because you can specify your paging strategy inside of your query. I argue that it's actually potentially one of the weaknesses of GraphQL because you need to know a lot about the backend infrastructure in order to maximize your performance on the front end. And so instead of, you're kind of pushing knowledge and responsibility of performance onto the front end as opposed to controlling it as a back end API consumer. And so there's a lot more kind of trust that you put in the front end, which you don't typically ever want to do because the front end is the most exposed, it's the most easily exploited, it's the most, and frankly, a lot of times you have API consumers that you don't even know who they are. They're just someone random off the street that's reading your documentation, and they could do anything to cause bad performance issues in the back end. So I think to me that's one of the actually disadvantages, unless you have a really tight knit team between your front end and your back end, and that's or you yourself are developing the full stack. That can be helpful. But yeah, that's I wanted to mention that of paging on GraphQL because a lot of people will claim that that's a benefit. I don't see it necessarily as a benefit. I see REST paging where you kind of define your strategy as a benefit because you can manage that performance on how you define your API and you can limit the number of pages that you allow or number of number of items within it because you know how much stuff you need to hydrate and all that kind of stuff. So yeah.
So this decision has been made, will be made in the very initial stage or on the go during the whole build process. It means
You
once
mean
the parents
like,
go,
you mean the paging, like the actual?
where means it's a front end or back end or what type of
Oh
front.
yeah, you make that decision based on the application.
Okay, but that will be done. Means the decision has been made very early stage in the very beginning, or
Oh, typically if you have experience, you'll make it pretty early.
Mhm.
Paging is one of those things that you'll notice, like if like JC and I are trying to get a job out real quick, we won't page because typically there's not enough data for it to make a difference. That's one of those that we'll punt on and we'll say, yeah, we can always add it later when if this system scales or what it is. You don't necessarily have to do that at first. Um, Only if at first there's just a crap ton of data, and you know, like you've preloaded your database, but you know, typically you're building systems and you're waiting for users to join and stuff like that. It's like, yeah, this could probably wait until you know it gets to be serious. And there's some routes you know that will never grow to a size that the front end can't handle. At that point, don't worry about paging.
And you can always structure your API such that you're not going to make any breaking changes when you move it towards a paging strategy.
Right.
So
Right. Yeah, exactly. And we do have paging strategies that we kind of build into our frameworks now that get kind of generated with it. So we kind of have an agreement. We don't necessarily implement it every single time because there is some complexities there, but we do kind of have a plan from the beginning on how we manage that. I think we've come up with a pretty flexible way without limiting ourselves. Plus, all of the APIs that we have through the entire stack that we've written and generated all use kind of the same thing. So you can kind of pass the paging all the way through to the database directly, and then it'll come back for you and all that kind of stuff. So it's kind of included as we go. You'll notice, right? Like everything we're doing, we're kind of doing it from scratch. And there's a lot of stuff you have to consider. Like we're kind of scratching the surface of like all of the details and things that you'll have to do in a production system. And that's true. Fortunately, from a Modesto technicity perspective, like we've kind of already built frameworks that kind of handle this already. And through the stuff that we're doing, you'll at least kind of know what's happening under the hood. It's rare that you'll have to build that from scratch. It's great if you build it from scratch because you'll learn it. But you know, if you're using a framework or a system or something, you know, typically those things will be included kind of in the box. Paging is one that you don't find very often in the box though, because it is so performance and data dependent. So that's a good question.
yeah, and I'd say one of the challenging things for paging is dealing with dynamic data when you're trying to page through something that's actually changing while you're paging. And I think that's why, for example, Twitter did a really good job of being one of those examples of how you can deal with paging tweets, right? You could imagine you're trying to scroll down to this giant list of tweets, and some are coming in at the same time. So maybe once you go to page two, you see something that was originally on your page one because you had something that got inserted to the top, right? If you go from most recent to oldest.
Hmm.
And so coming up with a paging strategy for that is definitely a little bit more challenging.
Yeah, yeah, without a doubt. Cool. Any other questions? We have a light showing tonight. Not necessarily a bad thing. I'm glad Beth Ann's here. You don't have anything that's going to totally destroy the entire office hours again, do you?
I'm afraid to ask.
Do you have a question? We'll answer it.
I'm getting where I can run the server, but I still can't get the Sumo GUI to come up. It from the embedded file. That what it does is it tells me there's an error in the operating, like the Python operating. So I've gone through setting everything up and I just can't, and I've tried this last week and I just can't. I can get in the container, I can get the container to work, but for some reason it just will not connect, like it won't talk to Sumo.
Are
So
you
I've tried
are you running Sumo outside of the container?
I have what I downloaded in the Docker file, and I can run Sumo. So I'm running everything in the container right now.
And you're running sumo in the container?
As far as I know, I'm running what the README file tells me to do. So I am following the README file exactly. Well, okay, it's I have to I am following it exactly the way that it tells me to do it, but sometimes I have to go in and use like pip 3 rather than pip because it gets unhacked. But other than that, I'm following it exactly, and as I said, I can get it to
I would make sure that you're running sumo outside of your container.
Yeah, BJ, that's the same thing I was running into last week where I was trying to run it in the container. And based on the README, it looks like you should run it in the container, and then once I popped out, it's fine.
So how do you get it out of the container then? How do you tell it to...
Just run it from your terminal, your basic terminal from your base Linux machine.
Yep. Yeah, so install sumo on your host machine.
Right, which I've done.
Okay.
And I can run it if I don't do any of this, I can run this without the container now.
Well, here, share your screen. At the risk of spending the rest of the night doing this.
I like that. Yeah, that's what I'm trying to avoid doing, because my goal is not to hijack this. Just a sec.
Well, at least there are new problems every time. It could be just the same problem over and over, and then we'd have a real big problem.
No, well, given the amount of time that it took me to fix this last time, let's see if this works. Okay, so I'm just going to do that. Continue. Share screen. Share desktop. Share.
All right.
So I went in and...
So just open up a new terminal.
Okay, you want me to close these then?
No, leave them open.
Okay. So.
All right, new terminal. Can you type sumo-GUI?
Yep.
All right, good, that works.
Yep.
So basically go into that folder that you have your wherever.
This?
Nope, in your terminal. Go to the shared volume that you've got, basically your workspace. So where are the files on your host operating system that you're operating on within your container?
For sumo?
No, just for everything.
Right there. Do you mean that?
No, like it's the development environment, right?
Right.
So go into development environment. Tab.
Okay, sorry.
I'm all about productivity, you know me.
Yeah, I got it.
All right, LS. And then go into projects. And then go to embedded, probably.
Did I do tab there? Nope.
Yep. Oh, well, then it probably doesn't exist. Do an LS. Oh, there's nothing in there. Oh, probably because we have to go to week 4 or 5, whatever. So go to week 4. Right. And then go to...
now I got to go back just a sec. This is going to work if I try doing that, right? Yeah.
The dev, it looks like it's in dev, and then week 4.
Okay, so CD.
Oh, good call, JT.
Okay.
And then go into embedded. Passing those coronas around. All right, and
maybe that's okay. Go ahead.
And then LS. And then why don't we create a virtual environment? So we're creating a virtual environment on your host machine. So you're not in your dev container anymore, right? You're just running this naturally on Linux.
Right.
And that's what you need to do in order to be able to see the GUI.
Okay.
So create a virtual environment. Well, yeah, I mean, you already have the. Do you have the virtual? No, you don't have a virtual environment yet. So do a virtual env.
Just in the regular.
Yeah, venv.
Yeah.
And fortunately, you share a. Nice thing is you actually share a kernel on Linux. It's one of the beauties of this Linux. So it's actually the same. So you can actually share virtual environments between your container and your host machine. And then, yeah, so you're there. And then now you can basically do pip install -r and install the requirements. And then you can, is your server and stuff running?
I think it's missing Tracy, though.
Yeah, it's missing Tracy because I think that's what you have to install. Although it should come up. No, it should come up with the.
You have to install sumo tools, apt install sumo tools, if I remember right, for Linux.
Or you can just do a pip install Tracy.
Does that work too? With the
yeah, that's what I've done in the past.
Yeah.
So is that okay? So
because sometimes Tracy's version is not up to date in apt or pip.
Oh, okay.
But it might work. Yeah. Yeah, it looks like it's not working.
That's okay. I can figure out that. But when I went, as I said, when I went by this, it said next to install Tracy, make a virtual environment. So I just followed through with this.
Yeah.
And then the vehicle Python was the one telling me that when I was doing it here, it was getting unhappy about the tool path that I had.
Yeah, because that tool path is not
within the development container.
Well, no, it's first of all that line 8 is not Python, that's Bash, so different.
Okay.
And then the second is I think those things are actually already included. I bet Sumo Home is already defined on your path because that's what Linux does. You can verify that by opening up your terminal again that you were in. And then do an echo, ECHO, space, $, and then all capitals, sumo_home. And you'll notice it's already kind of defined there. So you can get rid of that line 8.
Okay, so that I think that will solve my problem then. If that's, because as I said, when I have...
You still need not line 9 and 10. Because you still need to append that tools.
So I still need this. Okay. All right.
And you can do a command / to shortcut your comment back and forth.
Command /. Oh, okay. Took me a while to just find it in the thing. Okay. Then I think I can figure it out then. I can stop sharing and see if I can get it to work. If not, I'll...
Well, we can. Why don't you go to the your terminal real quick, if that's saved, and then try running Python space vehicle.py. And let's just see if it. You need to save that file. Vehicle.py.
Yeah. I got it.
Command S or Control S.
Oops. Okay, and then back to here.
Let's see if Tracy.
That's because I got to start the cloud again because I.
No, you've got a syntax error and it's not liking the F string. Can you type Python and enter?
I have to run Python 3.
Yeah, no, this has been, I actually removed Python 2 from my system. And it actually pulled it back down.
Your virtual environment installed Python 2 as opposed to Python 3.
Correct.
So I'll show you how to fix this problem. So
okay.
Do a Control D to get out of the REPL there. Okay, so let's do a deactivate, which will get you out of that virtual environment. And then RM, you're going to remove that venv. So -rf.
RM.
-rf space venv.
Okay.
And then we're going to install a virtual environment. Can you type Python 3? All right, that's 369 is good enough. So can you do a Control D and do Python 3.8? So just type Python 3 and then tab. Tab twice. It looks like you have only 3.6. That's fine. All right, so virtual environment Python 3. There's so type virtual env space venv or virtual env space -- Python equal.
Oops, sorry.
Equal Python 3.
Just a second. Okay.
And yep, and then venv.
Enter.
Yeah. So it will install
Okay.
pip. Okay, and now activate the virtual environment.
So just activate it. I don't have to say, oh, because.
No, so you have to do source venv /
Sorry, yep. Got it. Okay.
And then pip install, or verify this, do a Python, type Python. Yep, 3.6 now. So control D, and then do a pip install space -r space requirements, and then that'll install the requirements, and then remember tab, and then what you can do is now Python space vehicle, and that f string will should work. There you go. So now just run your server and stuff, and you're good to go.
Okay, awesome. Thank you.
Yep.
Good.
All right, who's next?
Are you going to talk about the thing that you didn't finish talking about on Thursday?
Yep. Yeah. If no one else has any other questions, I'll do that, because I don't think we need that much time here.
Okay.
So I'll let you guys think of any more questions for like 1 minute here while I deal with Mercury Marie. Just a second.
PJ, one last question regarding the Docker Compose file. So there is a version 3.3. That's what we are using right now, right?
Yes, yeah. There's Docker Compose has been through a number of versions, but we typically use, that's what I've seen, 3.3. I could read about it real quick and tell you about them, but I don't know what the difference. I think there's minor syntax issues or differences between the different versions.
Oh, okay. So the Docker will get the latest version, irrespective of how many versions it is, or
So that's that version in your Docker Compose file is just what version of the Docker script you're using, the Docker Compose script, because different versions of Docker Compose, specifically that YAML, have different support. Like 3.3, like one of the things I think is the difference. Like your build args are a lot more verbose. Like you have a lot more control of your build args in Docker Compose 3.3. Now, in terms of your actual image, that's done by a simple colon, by tagging your Docker file. So, like at the end of your image, if you had a different tag, you would, let's say your image was called my image, you would do my image colon whatever the tag name is, latest version 1.0, a Reeve 25, whatever, right? Whatever the tag is for that specific build.
do you define that on the Docker file to which one to pick, or?
Yeah, basically you have to read the documentation. Like in the registry, if it's a standard registry, the registry itself is would list all the different tags, assuming that it hasn't been purged or whatever, and then you can kind of get from there. There's probably I don't know, maybe a JC. Do you know the command to get? I think you can list. I think there's like a Docker remote list that will list all of the specific tags available on the registry that you're asking for that specific image, that you can like choose from. But I think it's like Docker remote ls or Docker image remote ls or something.
Well, another option would just to be to go directly through whatever web access you have to that registry and then look at the different tags. I mean, on Docker Hub, they'll show you the full list of tags that are available for the different versions, as well as if you're using a GitLab registry, you can see the tags available there too.
All right, so let's talk about more databases. More database stuff. Okay, so we've got so if you remember, what we did was we defined our data model here, right? Now I'm just gonna talk about relational stuff. And I have not thought about this or practiced this in any way, shape, or form, so might be kind of rocky. So bear with me. But the basics for this are we only really handled one table, right? And in what case, right? What even simple case do you only use one table, right? In fact, it's probably not good practice to push the model and make into a vehicle table. Why would that be? I'll open the floor. Why do you think that's why is this design not scalable? And I kind of gave you a hint, right, with that make and model. But why do you think that's not that there's problems with those specific two things? Anybody?
So can you please repeat the question one more time?
Yeah. So right now we've got, this is the relational database, right? And that's modeling, our data model is basically modeling a vehicle. And we specifically, in this case, have a vehicle table that stores information about the vehicle, right? But we shove this model and make in here. But if we think kind of from an architecture perspective and a scalability perspective, that we might want to support future models and makes and stuff. I'm getting the answer now. Future makes and models, then that's probably not good to just shove a string in here. And why is that? Any ideas? So right now, like, let's say we have a Civic, right? And the vehicle has a VIN. Let's just say 123 for the sake of argument. And the make would be Honda, right? And the model would be Civic. And the year is whatever, 2018, 2019, whatever, 2020. And what we're saying here is that we would actually shove the make in here to be Honda, right? As a string. And we would shove the model in here to be Civic as a string. Why is that probably not a good idea? And not only is it not a good idea, what is the alternative? And what should we do from an alternative perspective?
JSON format file.
JSON.
Is your data size end up expanding because they're all strings and you could just reference to another table by index?
Exactly. So it has to do with scalable data patterns and good integrity, good data integrity. So in some sense, you can think of, if we're designing a general connected strategy, you might have 5 makes. Or let's just say we're Honda. We're just implementing as Honda or FCA or whatever, GM. But we might have 5 vehicle models that we want, or 25, or more realistically 50, right, of these connected vehicle type models, right? But the thing is, we don't necessarily ever want to just shove in a string like Civic, Accord, you know, CRV, do they even make that anymore? You know, all that kind of stuff, right? What we want to do is we want to actually carry more information around with that, because we may want information about the model, like, you know, what the standard body size is, or what the, you know, what the configuration is. Is it light duty? Is it heavy duty? What, you know, how many, the model might indicate what the size of the engine is, right? It's 4-cylinder, you know, a 6-cylinder, whatever, right? So what we want to do here is, if we wanted to store that other information about the model, well, I guess one option is we just add crap here, right? So like model, you know, engine type, right? And we just start, but that'll get out of hand really quick, right? You're basically shoving all this thing, and you're going to have to set those fields for every single vehicle. So even if you have 20,000 Honda Civics, you're going to have to duplicate basically all those Honda Civics information. And there's really no reason to duplicate it.
Isn't that already embedded in your VIN number though? Or is it that you don't have any way of decoding the VIN number so that it's going to come out for you in your table? The VIN number is good.
No, you're right. You can decode that in the VIN number if you have the algorithm to figure out what the decode is, which is standard. So you could depend on that. I'm not a big fan of, you know, obfuscated information for the sake of obfuscation, which is really what that is, right? But even if you did define it from a VIN, you would still need to be able to reference it back somewhere. You still need to define, okay, this structure in the VIN, you know, digits 8 and 9 in the VIN correspond to the week that it was made and the, you know, the year, and then, you know, what model it is. You still need to store that in a database somewhere, right? When you use that algorithm to figure it out. So that's more of a connection kind of thing, right?
So is it not scalable because you simply there's too many variations in what you have here to be useful?
There's too many variations, but it's more like it's just redundant. So you may have 20,000 of the exact same Civic model, but there's no reason to just constantly fill in the engine type, the body type, and everything in this vehicle, because it's going to be copied over 20,000 of these records. Like, what's the point, right? It's much easier to tear that out and abstract it into a single record and then reference that single record. So what we can do is remove this.
I was going to say, not to mention if somebody's typed Civic with a capital C at the beginning and another one with a lowercase c, and then maybe you have another misspelling, right? How do you control, right, what is a Civic, right? And then you get some ambiguity there. It just turns into a data cleaning nightmare.
Yeah, and that's the big thing about data science, and where most large enterprise who have a ton of data, they don't, one of the biggest challenges, they don't have clean data. So it's basically useless to them because of that exact problem that JC just said. Is like, you know, some guy came along and decided to not capitalize Civic. And so you got to do all this processing and just waste time and effort and money and all that kind of stuff to get it. And there's no uniformity across, and there's this disparate stuff. So that's why we're always really focused on doing the right data structures first, right, from the very beginning. That's why it's so critical, and why we always start with the data model. It's so critical to get your data model right, because that's what's going to make or break you in your scale. All right, so let's make another table. Let's do vehicle make. I'm sorry, vehicle model. And let's say there's a few things about a vehicle model. You know, maybe we'll just do model number, you know, powertrain type. And the powertrain type, what we'll do here is, as you can see, the type, you could actually do the exact same thing, right? You could make yet another table of powertrain type, and then you could reference that powertrain type. But here, I'm not going to go crazy with that just for the sake of time. I'm going to make something called an enum. And the enum is just an enumerated type. And I'm going to say, you know, V4, V6, VEV, right? And maybe HEV. Not null, and we'll default it to BEV. Because apparently there's Civics that are a battery. Full electric Civics. I don't think that's the thing. And then maybe we could do a start year, right? And maybe an end year. So like what that, you know, the 5-year cycle or whatever typically, right, that they're on. And then we could do an image URL for it, and maybe you can inherit that at the vehicle level, all that kind of stuff. We're going to leave the boilerplate created, take the VIN out. That doesn't mean anything. We'll just do a number here. I don't know what that means, but it's whatever the specific number is, and then, you know, the name of it. All right, so we have this. We have these two tables now, but we need some way to link, right, this model to this table. And so there's a special keyword in MySQL, or really all relational databases, called foreign key constraints. And what that means is we can make a foreign key constraint on this column to some record in this table. So how do you do that? Well, it's relatively straightforward. I'm going to have to go and look for an example of that somewhere. All right, let's look in I just pulled up a random one. Actually, JC's been working on. I'm going to copy and paste out of it. It's called cribbing code. Do it all the time. And then let's see here. I'm going to paste it in here. And you'll notice that we have a constraint. So what we're saying, actually, this is the wrong place. I don't want to do it here. I want to do it here. Actually, I want the constraint there. And what we're saying is that we want the constraint, and we're gonna make a name. This is like a variable name for the constraint. We're gonna call it model. We're gonna change this to model ID. We're gonna make this a big int, and I'll describe why we're doing that in a second. So we're going to change this, and then we're going to say, well, the constraint is vehicle, and the model ID on the vehicle, and it's FK. FK stands for foreign key. This name doesn't matter. Purely convention. You can name it whatever the hell you want. Doesn't matter. But I do it the way this. I just say, all right, first thing I'm going to put in here is the name of the table, the column that it references, and underscore foreign key. So I can reference it later if I need to. You don't actually have to put this if you don't want. And then we're going to say what the foreign key is. The foreign key is model ID, because that's this field. What we're saying is the foreign key constraint here, and it references the vehicle table, the vehicle model table down here, and it references the column ID. And that's actually why I changed this type to big int, because it needs to match the ID type of this. So we've just very simply created a constraint from this table, specifically this column, to a record with this ID. So if we were to insert values into this table, this vehicle table, we would actually insert, let's say this had we created a vehicle model of ID 5. So Civic, let's say there's 5 records and there's 5 vehicle models in our database, and just so happens that ID is 5. This model ID would be 5 if it referenced the ID of this vehicle model table. So I'll give you an example of that here. Let me see if I can pull up Tables Plus. And I need FSSE vehicle. All right, so we have 3 things here. We're actually gonna have to clear this out, right? Because we just changed our data model. So I'm going to do mysql-u root-p root, and I'm going to say data model. And it looks like can't connect because I need to put the host -h mysql because I'm in my dev container. All right, and if I reload this, you'll notice that it added my vehicle model table, and of course it cleared out all the data there. And so if I go to structure, we'll notice this, but the model did not change the model ID. And the question is why, and I think it's because I didn't save it. So let me try that. All right, so you'll notice it's big int, and you'll notice down here that there's an index, and that index, it actually automatically created an index on that foreign key constraint, because it has to in order to keep track of it. And it references this vehicle model ID here. All right, so let's just let's make this really obvious. So let's insert a a record here. I'm going to go over here, and we'll just create UID. I think this will work. Hopefully, we'll just this is just a vehicle model, so we'll just keep with our stuff. So Civic for start year 2000, 2005. It's an old Civic. Description: old Civic. Image URL doesn't matter, and that's automatically created. Let's see if we can insert or is this not the insert? Crap, did that wrong. Sorry. No, it inserted them. So can't have default value changes are reverted. All right, so I can't do that. I need to go find an actual UID to put in there. Let's see if that works. Let me delete this row and see if it'll upload that. All right. Don't know why. All right, so we got 2 vehicles in here, ID2 and ID3, or vehicle models, sorry, right? And so what I want to do now is I want to insert a new vehicle. And the ID will auto increment. And I will just do a new UID there. The name is going to be my Civic, right? Because now we're doing an instance of a vehicle. But the model ID needs to be one of the models that we inserted, right? So, and if you remember, those had either ID 2 or ID 3. So let's say it's ID 3. We have the make, we'll just do this, Honda. We should probably do another foreign key table, right, for the make, if we're going to do multiple OEMs. Year 2004, description, color red, I think. And then this is, I forget. I think that
just 25500.
Just red.
Yeah.
Right. Okay, and then no image for now. We'll update that. I think, yep. So you'll notice that this model ID references this make. Okay.
Is this something like linked lists or something? You're linking the two lists with?
Yeah, it's very similar to a linked list concept in data structures. You're basically linking a column or a row to another row in another table. You're linking them as sort of a linked list. So you can imagine that technically you could make a linked list because you could have another column that links to another table in there, and you can create links all the way through. And in fact, you can foreign key constraint a column to another row, or a row to another row in the same table. So you can like link those things together. Like we do this a lot when we're talking about categorization, and we want an infinite depth type of category, but it's all in the same table. We just say this category can reference this category, which can reference this category, and then you can just do a linked list of rows that just link to each other within categories, subcategories, and stuff like that. So what that means is that now that we have this make and model, what we can do is we can actually do a hydration. And this is where these hydrators start to become really critical. Because as you can imagine, I won't actually go through it because it would create, well, I might go through it. Yeah, I don't know. We'll see. So let's go to our index.js here. So we have, we can do it. That's fine. So what we have is we have vehicles, vehicle UID. So we have this hydrate vehicle. And you'll notice if we pull the hydrated vehicle, you're going to get basically, and you hydrate it, what's going to happen? You're basically going to pull the vehicle, but you're just going to return a model ID, which is just an integer. And specifically, it's an integer within the database, which if you remember the last week, we talked about that being not a great thing to expose the inner implementations of your database, specifically your IDs and things. Not to mention the fact that it's completely worthless to the API consumer because they can't even request it as an ID. They have to use a UID. So there's really no way. So that's why a hydrator is important, because that's what this hydrator would be responsible for. So in this hydrator, we can now do a select on the specific model ID. So now we can say, query async, but now there's a few things we have to do here. We have to, gotta go back here, open this up. We have to import this query async into our hydrator. We only need that. We don't need all that other stuff. So we need query async. We're gonna, query async, SQL We're going to select vehicle model. We can say select star from a vehicle model where model ID equals, and then values, we can say vehicle.model ID. And then we can say let vehicle model equal await there, right? And then here's the other cool thing. What we can do is we can say vehicle.model is equal to vehicle model. And so now we get this nested JSON that's consumable by the API. But what you would probably do is you'd probably make a hydrator for the vehicle model and hydrate it there. And so you have these chain of hydrations because you might want to rip out the IDs and stuff. And the other thing is we want to delete vehicle.model ID off of this because the model ID doesn't matter anymore, right? We don't want to necessarily expose that detail and it's worthless to the user, so to the API consumer. So there's no reason for it. So we basically can pull all of this good stuff from there. All right, so that's relatively good that we have that. You can also do the same thing for vehicle make. And you can start seeing now the vehicle model depends on the vehicle make, right? And so you'll have this more deeply nested vehicle make. And so you probably end up removing the vehicle make from here, from vehicle, from an architecture perspective, and moving it up here into your vehicle model. And then you'd probably make a vehicle make table, and then make yet another foreign key constraint up to the vehicle make table. Right, all of those different things. This is such a critical thing in relational databases. We do the same thing in Excel spreadsheets, right? Where we reference one cell to another across workbooks or across columns or whatever. It's the same thing here. We're just doing it using foreign key constraints. Foreign key constraints are one of the most common kind of concepts through all relational databases. In fact, it's a very core piece of the relational calculus, is what we call entity relational calculus. Is the kind of theory behind databasing and all this kind of stuff. You can read all about it. You take an entire multiple college courses about databasing and the theory behind them and how you describe them and all this kind of stuff. Constraints and key constraints are a critical piece of database stability and design patterns. So very common thing. So anyways, that in and of itself is kind of what I wanted to cover, which we didn't have time. As you can see, it's a relatively critical detail, but you know, if you don't see it, it's not like the end of the world. You figure it out, kind of thing. But I wanted to call it out as this is how you kind of architect database and why it's so critical. And you don't expect yourself to know how to architect a data model from the very first thing you do. I mean, that takes a lot of experience. We've been through it a number of times. JC, why don't you talk about how you picked up, data model, because you do a lot of data modeling now after a few projects.
Yeah, I mean, I think it's really an experience-based thing, right? You get into a project and you have a general notion about, the form and shape of different types of data. And when you translate that from working from the API to actually seeing a real example in a database, you get a better feeling for how you should be setting up constraints. Back to one of the initial things we were talking about with paging and whatnot, when you start thinking about performance, you get a better idea in terms of, maybe I could actually just directly push some kind of a query down into the database instead of having to combine a bunch of tables together. And so I can't give a better answer other than just experience.
Yeah. So don't expect yourself to be a database whiz or data model whiz. I mean, this is something you have to kind of rely on more experienced people and learn from them. So if you work with us after, I'm not, we would never just give you the project of, hey, make a data model. Like, that's not something that we could expect anyone to do. That's something we have to do as architects and something you have to kind of learn and kind of grow into. So, but you'll see these types of patterns through it.
So it's the art of figuring out how many layers you make of this and how efficient that's actually going to be versus
right.
Okay.
It's an art. Data modeling is an art. It really is, and it's. I said something kind of critical. I kind of glossed over it, but something critical that I said before was your data model is what's going to make or break you. And unfortunately, it's the first thing that you do in your project when you start a new project. So it's so critical, and that's why you don't really rely on things, and you don't rely on a non-experience, right, to do that. You really rely on others that have done it before, if it's something important. With that said, of course, you got to start somewhere. But I think the big thing is you'll notice that in my style of architecture, I way over-design data models. Like, I may know that this data model will never grow, or like the business idea is just dumb and no one's ever going to buy this product. But there's like an inherent JC knows what I'm talking about. There's like this inherent need that I feel to make sure that the data model is scalable. And so we'll design things in like putting an additional table and doing a foreign key constraint where it's like, do we really need that? Probably not. But we're going to do it just in case. Because if we don't do it now, that's going to really screw us later. So I'd rather err on the side of over-architecting a data model than I would getting caught with my pants down in the middle of a project and have to restructure every single thing and add like 2 weeks to an existing, massive architecture. Not to mention the fact that as engineers, we design every system, particularly in connected systems and IoT, we design them for machine learning. Like the IoT is kind of a means to an end, so to speak. Like we need to get data, so we do IoT to get data. But what we're really doing is we're getting data in order to model, right? And build predictive models and to do all of the things that we want to do as engineers. These are just tools that we use to get there. And one of the most frustrating things about machine learning is your hyperparameter tuning and all that kind of stuff is so dependent on your features. Like it's all about feature selection. That's what machine learning is all about. AI, whatever, all the buzzwords. It's all about feature selection. Even just traditional dynamic modeling optimization. It's all about feature selection or parameters, right? Variables, things like that. And so what it really comes down to is that feature selection always comes down to your data model. Because it's your data model that's defining the features you're going to feed into your models to make your predictions, right? And so if you have an experience of what you typically will do and when you train models, especially when you talk about machine learning type structures, that's the way I think of things when I'm designing a data model. So it may look like I'm abstracting things or I'm categorizing things way too much in a data model, but I'm doing that specifically because I know, this might be a feature. I may need to do a classification on this. It's going to be a hell of a lot easier to classify this specific feature if I have an actual type table for this, as opposed to just shoving a bunch of data into it and then saying, it's someone else's problem. Oh, that's the data scientist's problem. He's got to process that later. And that's what all software engineers do, unfortunately, because either they're not aware that machine learning is a thing, or it was built 10 years ago when machine learning wasn't a thing, right? It wasn't even a glint in a developer's eye kind of thing. And so what's going to happen is that when you go to your data science team, your analysis team, they're going to hate you because that you basically just added 6 months to 12 months of just tedious data cleaning, which is about 95% of machine learning. That's what I always say when students come to me and say, hey, I want to do machine learning. It's like, oh, you want to clean data? Great. Go over in the corner. Here's some data clean. Because what people don't realize is like the hero's work of training a model and, getting AI and reaching sentience is about 5% of what you actually do, right, in machine learning. 95% of it's just writing Python scripts to clean frickin' data. So it's not a glamorous sort of thing. That's why you can see a lot of, data scientists who just graduated from business school being data scientists because they're just going through painstakingly in Excel spreadsheets and fixing data. That's all they're doing. Sorry, Beth Ann, but I mean that's all they're doing, and that's why like this esoteric data science title is being given to kids right out of business school, because that's all they do. They're not building models. They're not doing any of that kind of stuff. They literally are glorified data cleaners. So that's why data models are so freaking important, so that you don't add 12 months to your prediction model stuff, because that's what everyone needs now and everyone wants to do.
So if you structure it, you have this way that you structure it, that you have the architecture, and you say, I always try to do it this way, where I always keep scalability, even if I know that I have a project. Does that allow you to go and take code and pull it in? Like, can you start then almost from a template and say, I know I'm going to pull these things in, which would speed you up a lot than if every time you do it, you've got to go and design the model again from scratch?
Right. Yeah, so we typically like think of things like, we've done enough machine learning projects and things, even just on our own or for clients or whatever, that we typically know what kind of models we're going to use. Like, we're going to start with a random forest. We're going to do a convolution neural network. Like, we generally have an idea of what those model forms need to be later, and so that helps us kind of decide what those structures need to be in terms of scientific data. If you're making a social media app, it's kind of like whatever, like who's going to know, right? Or NLP, right? And just shove it in there. Let's just make sure that we're not going to get screwed from a design perspective and feature kind of not actually a machine learning feature, just like, product feature sort of things, right? So it depends on your application, but like, you were asking about structure. Do you have a common structure? Yes. Where I pulled up, I don't even know where I did it. Maybe I closed it, but I pulled up an example and I copy and pasted that foreign key constraint. That was something that JC was working on today, I think. And I was able to go to his file, which I'd never looked at. Sorry, JC, I probably should have to review it, but I never did. And I knew that I could just look somewhere in a data model, random data model somewhere, that there was going to be a foreign key constraint. I looked at it, just copy and pasted it. Because we're doing things really consistently, and you just kind of fall into these patterns, right? You're starting to see these things, right? We're doing this enough over the last 5 or 6 weeks. It's all pattern-based stuff. It's just rehashing pattern after pattern after pattern, and it's just really getting exposed to those initial patterns is what you need. At that point, it's just kind of learning the tools and getting comfortable with it, getting experience, but they're just patterns over and over.
There's one other thing. Did we mention the importance of having a well-built data model when it comes to deployment and updates?
We didn't. We will though, but you can talk about it. Give them a taste of deployment in the coming weeks.
I mean, it's so. I think once we get into deployment, we'll talk about continuous integration, continuous deployment, CI/CD. But one of the things that you get into, the idea is, as you're building your code, you want to deploy often, right? And I guess the principle behind it is that you don't want to make some huge feature changes, right? And try to deploy that all at once. You want to capture the bugs, if there are any, in the process, right? Obviously, we don't write code that has bugs, right, BJ?
Right.
But anyway.
People lose fingers. People lose fingers if there's bugs.
But it allows you to roll things back really quickly, right? You're doing these constant incremental improvements. But part of that, what you'll notice is that, sometimes when you need to add a feature, there may be a point where you realize that your data model doesn't adhere to your needs at the time. And you may need to update the data model in order to get that feature out. Well, when that happens, it actually is a lot more of a painful process than if you're just deploying code updates. Because what really controls the behavior of your cloud system is the data, right? You can change, for example, a route handler and really not be worried about any other side effects of that. And it's easy to roll that back, right? Because it's something that doesn't actually have memory. But the moment that you actually start changing the data is when you can cause irreversible changes. And so that's why it's such a such a more risky and such a more involved process, which is another reason why you don't want to have too much churn on your data model.
Right. Yeah, performance is a huge thing. If you have 1 billion rows in your relational table, which is good sized, and I'll try to apply an index, you know how long it takes to index that column? Over 1 billion rows, freaking long time. So you need to make sure that you're smart about how you alter columns and things like that. You don't want to be doing that very often.
When you talk about deploying it, are you talking about that you as a team put together the product and you deploy it to the team? Or are you talking about actually doing it where you would deploy it to a customer? I assume you aren't going to give it to your client until you've kind of worked through those bugs, or do you kind of do that as you're developing? I mean, do you let your clients see what you're doing and test it out in kind of that alpha beta mode, or do you kind of play with that within your own team before you're willing to let your client have it?
Yeah, we don't do QA. Our customers are the QA team.
No, I see you follow the automotive model.
Yes, yeah.
Yeah, exactly.
I think we follow the engineering model.
Okay.
When we say deploy, what we're talking about is actually deploying on a server to where it could be publicly accessible. Because as you've noticed so far, we've just been working on it locally, right, in our dev containers on our machines. But at some point, we're going to want to deploy. When I say deploy, we're going to want to put this code, the cloud, onto the actual cloud. So put it on a server up in the cloud somewhere so that real vehicles or someone else, like a phone, can access it. So that's what we mean when we say deploy. It means making that publicly accessible and doing all you have to do.
I mean, that's its own rat hole. I mean, there's DevOps, which is you can have as an entire field and career is just involved in DevOps and deploying these systems, because the way you deploy a system in and of itself has its own architecture.
Yep.
Right.
Yep. Kubernetes, Docker, and all those things. It's DevOps stands for development operations, right? You sometimes hear it called sysops. System admin is the old way. Sysadmin would be kind of what DevOps has become. DevOps is let me see if I can get this right, because I used to think about this. So like an architect should know everything below him. Like a system architect should know everything, like all the tools and everything below him. Like a software developer is the next level. So our software engineer is the next level. A senior software engineer, whatever, like a coder is the next level. Needs to know everything below him. The DevOps engineer has to know everything below him, and then the QA needs to know everything below him. Now you could argue there's a whole level of things, but when I say needs to know everything, basically a software engineer should be a DevOps engineer, because they need to know how their code's going to be deployed, and they need to structure it as such. An architect needs to understand what the software engineers are doing and the DevOps engineers are doing. The DevOps engineers basically need to be able to take the code and they need to deploy it within the context of the system that they're doing. And like JC said, that's a whole field in and of itself. I mean, it's a massive field. Very difficult, very detail oriented, very frustrating. It's also very rewarding when it works, rarely when it works. And so, you've got all of these different things, and then QA is just, I just need to break shit and tell them that it's broken. So they basically need to be users of the system. So, from that perspective, like that's kind of the hierarchy of skills you need to know. And so what we're talking about is like through this entire boot camp's architecture, right? You kind of need to know everything, or at least be exposed to everything, to kind of know how these things come together and how to plan for them. You don't have to be experts in any one field, but enough to know how to architect, right? And so you'll sometimes hear that DevOps and software engineers need to be flipped. Like DevOps need to know all the software engineer. In fact, a lot of software engineers like kind of graduate to being DevOps engineers if they tend to like that kind of stuff. they're more configuration oriented, things like that, they may actually become DevOps engineers as a career. Be very lucrative and they're highly paid. The problem is with DevOps, it's like SecOps, security operations, is like your bosses always say, when things are going great, they say, why are we paying you? And then when things are going really bad, they're like, why are we paying you? So, you can't really win in a DevOps or security ops sort of, or an IT type position, because if things are going great, that means you've totally automated stuff, and you're constantly tinkering and making sure that stuff, but they never really see it, right? It's kind of an unglamorous sort of no fanfare sort of job. But if you like details and pulling your hair out, throwing your computer across the room, DevOps is the career for you.
I mean, as another analogy back to automotive, I would draw a couple parallels with calibration engineers. Mm-hmm. So if you think about it in terms of when if there's a launch issue or something, since calibration is one of the last things that gets changed in the design of a vehicle, in terms of quick fixes or when something needs to be rolled back, who is it that gets called? Your calibrators, right? Like they're the guys that got to come in on Saturday to handle some launch issue, right? And they can, because that's the quickest and least expensive thing to tweak, right? And so because you're the guy that's closest to the end of the process, right? So when you're DevOps and a server's down or something needs rolled back really quickly, guess who's getting called in, right?
Yep. Yeah, you're on call most of the time. Now, the technicity, we do all of it. We're DevOps, software architects, and everything, so we're basically 24/7 on call. We're the ones who get really screwed in all of it. But yeah, that's a good analogy. It's the cow guys that that get screwed.
Yeah, they're the ones right in the vehicles, right?
Yep.
The DevOps guys are the guys actually like putting the software out there and seeing it run.
Yep. And like I said, it can be very rewarding. Like we'll spend whole days, like JC and I and the team, we'll spend whole days that we'll dedicate to DevOps, because it'll be like, hey, we need to deploy this system, and we'll set aside a solid 6 hours. Even if though we've done it a billion times, there's always something that's different. There's always something that you run into, or there's something in that one system, that detail that just effed everything up. Like that freaking Docker context, right? It's like, we got to change this, and it's like a cascading whole like thing. But our latest thing, Justin, was actually relatively painless. I was surprised. I think we've finally done it like 150 times now. That pretty much seen everything.
So
keeping everything in the same environment really helps too. We don't worry about Circle CI too much anymore.
Right.
You said you use the Docker do you keep using the Docker even after it's deployed?
Yep. Oh yeah. In fact, Docker is where Docker in development is kind of a new thing you don't see very often. We're kind of blazing the path on that one. A lot of people don't do that. Where Docker really starts to shine and is very powerful is in deployment. But if you start it in development, then it's actually a lot easier when you go to deploy. Most of the headaches and hair pulling that you end up doing in DevOps is because you're using tools that were not used in development and platforms that were not used in development. All the pain and suffering like you guys all went through just get your Docker environments run up, spun up. Imagine developing things on Windows. Let's say you just got them running on Windows, because you could have if you'd spent enough time. But now you're like, okay, I don't want to deploy this. But you don't have an option to deploy on Windows. You're deploying on Linux. Yeah, good luck. You're going through that whole thing again. It's just such a pain. So that's why you kind of start as you mean to go, right? And so, using Docker from the get-go is good. But Docker was really designed as a deployment tool, not as a development tool. It's just kind of grown into a development tool, and we're kind of, like I said, we're blazing the path. You don't see that very often, what we're doing with our development containers. You're going to start seeing more of that, I think, but you don't see it much. But it's going to pay off when we actually go to deployment, because we're already used to it. We already kind of know, and we're already running on the platform where we know we're going to run on. we've already developed on it. So you're not getting these weird little seg faults or like, oh, I can't find this file, or oh, I can't use this bash keyword. And it's like, oh, because we're using a different version of bash on the server. And it's like, after 6 hours, you find that. And it's like, oh, the source keyword isn't supported on it. I'm like, oh, geez. And of course, half of it's not exposed to you because, it's up in a server somewhere. So, you're pulling your hair out. Like, why is this failing? Because you only see half of the actual error message. It just snowballs. Sorry, Justin.
A fun one we dealt with for a little while was the fact that if you look at the way MySQL is implemented on a Macintosh, the tables are actually case insensitive.
Yeah.
And on Linux, they are case sensitive. And so there would be some cases where you're working in your backend and you're writing data to a table, and let's say it's a case where you have an acronym in one of your table names. And I think one of the unsolved debates on what you should do for camel case with with acronyms is whether or not the acronym itself should be all caps, or if it should start with a capital letter at the front and go then. Well, let's say you didn't pay attention, you violated the precise way that it was written in the schema. It'll run just fine on your local development machine. You go up to deploy, and it's littered with those kind of bugs. And now you have to debug everything on that system, and that's not a really easy find, search, replace operation.
Right. And that's when you find it, right? Because you don't think of case sensitivity as being a thing. So you're like pulling your hair out, like, that is the exact same table word. Why can't it find that table? It's right there. And you're looking at it and you're like beating your keyboard and you cannot figure it out. And it's like, oh, well, it's because it's case sensitive. So it probably will take you 2 hours to realize it's because of the case sensitivity. At that point, you're like, oh, shit. Now I got to go through and fix every single capital A all through this thing. It's not that easy. It's not a search and replace. So yeah, deployment issues are very frustrating. That's why DevOps engineers get paid a lot. So yeah. Cool. Well, I wanted to bring that up. There's actually a lot. So if you guys want to do some homework, you can make a new route to make a post a new make, put it in that table, and I will get checkout -b. I'll do FKs, foreign keys for foreign keys, and git add. And I'll push that into week 5, that branch. It's called FKs. So you can look at the table and everything. What you can do is you can make a hydrator, kind of like what I showed. You can make a new route that you can post a make, or you can put it directly in your data model if you wanted to, just to have it. You could do insert into vehicle model. You can say set, UID equals to UID, and then you could do name is equal to civic, dot, dot, dot. You can do that too.
You're not sharing anymore, BJ.
Oh, crap. Sorry, guys. So you can do an insert in here so that you don't have to actually make a route. It'll just appear in your data, in the data model. So this is valid SQL. So civic name number. I think that has to be a string. I'll challenge you guys to make another table with foreign key. I think it'd be kind of cool for the make. Don't need to do a powertrain type because there's a start year and end year, and don't need any of that other stuff. And so this should work. Yep. And so now if we do that and we refresh this, there's already a record in here. So you could just basically use that from then on. but maybe make a route that maybe make a route that gets all the makes by UID, and then maybe you can add the make UID to the post when you provision a vehicle or something. And then once you do that, then do the code in there and do the hydrators and all that kind of good stuff. It's just pattern stuff at this point, right? Pretty simple kind of coding. It's just, obviously fighting through the code stuff because you guys aren't comfortable with the code yet. But it's a good way to learn. Conceptually, it's straightforward, but it's that simple process that actually covers a significant amount of content, particularly in the code. So I'll challenge you guys as some homework to do that. Happy to help too. Give you guys kind of some pointers as you ask. If you do that, and you're able to do that pretty successfully, you're doing really well in there. You're doing really well. So that's good. All right. So just to prove it to you guys where that is. Did I stop sharing again? Oh, crap. I did that not in this. Crap. All right. Sorry, guys. All right, now that data model's in there, which is really the only change we made. So there, and then edit your code to use that data model. It should still work actually. It's just a matter of no, it won't actually. It'll break, but you'll have to fix it. You'll have to figure out how to fix it. That's good. So if no one asks me any questions, I'm going to assume you guys are all awesome and you figured it out. So please ask me questions if you can't figure it out. Cool. Any other questions?
No, that's great.
Cool.
See you on Thursday.
See you guys. Stop while we're ahead, right?
Yeah. See you Thursday.
All right, guys. Thanks.
Thank you.
See you guys.
Thanks.
We're gonna